Hello, this is mathjazz from Almost Cool. This is the second video in our series of videos on the box modeling problem. In our first video, we set up a function that described the volume of a rectangular box, and we found the domain of that function. If you have not seen this video or done this problem, I recommend watching that video, doing that problem, and then coming back to watch this video. In this video, we'll be taking the derivative of the function from video 1, and we will be studying it a little bit. Here's the problem statement. Suppose that you have a rectangular piece of cardboard of width 24 and length 16, and you cut squares of side length x out of each corner so that the resulting piece of cardboard can be folded into a box. Part C. What is the derivative of the volume function for this box? Part D. How is the volume changing when x equals 2? The figure below shows the flat piece of cardboard with the x by x squares cut out of each corner, and on the right it shows the resulting box that we obtain when we fold the flaps from the flat piece of cardboard with the squares cut out, when we fold those flaps up and glue them together into a box. Pause the video now to solve these problems, and unpause them when you're ready to see the solution. Part C. From Part A, we know that the volume function is v of x equals x times 24 minus 2x times 16 minus 2x. Taking the derivative of this product is possible. We could use either logarithmic differentiation or we could use the product rule several times, but at this point it's easier to just multiply everything out into a polynomial and use the power rule on each term. So we do just that. We get v of x equals 4x cubed minus 80x squared plus 384x. So using the power rule, we get v prime of x equals 12x squared minus 160x plus 384. Part D. We plug x equals 2 into v prime of x to get v prime of 2 equals 12 times 2 squared minus 160 times 2 plus 384, and when we add that together we get 112. What does v prime of 2 equals 112 mean? It means that the instantaneous change in the volume relative to the to the change in the length of x is a gain of 112 cubic units of volume per additional 1 unit of length. So we can think of it as if the volume is changing the same way, it's growing at the same speed from 2 to 3 as it is at the instant when x is 2. We would see 112 units added onto v if we added 1 unit onto x. It's kind of like if we looked at a speedometer on a car, we would see a speed. We might see like 45 miles per hour. Now that means that if we did not change our speed, 1 hour later we will have traveled 45 miles. That said, just because the speedometer says a speed doesn't mean that you will hold that speed constantly for the next hour. So what will happen in this function is eventually we'll hit a point where the derivative gets smaller, because as we cut more and more out of the corner, even though the box is getting taller, the sides are getting shorter, and that will eventually become the dominant force and give us a smaller and smaller box. So initially, a small x will mean a short box that can't hold very much, and then as x gets bigger, we get a taller box that can hold more, and x continues to get bigger. Eventually we get a very tall but narrow box, and it can't hold as much anymore. There should be some point in the middle where we have a maximum volume for our box, But at x equals 2, we get it's still increasing volume when we increase x. So, that's to sum up, since v prime of 2 is positive, that means that making x a little bigger, that is cutting a little bit more out of the corners, will make a little bit bigger volume of a box. And that if v prime of 2 were negative, that means cutting a little bit more out of the corners would make a little bit smaller of a box. Thank you for watching this video. Contact information is on the screen, also down in the description of the video. I hope that you're enjoying learning calculus. I hope you're also having a great day. Thank you for watching the video again. Goodbye.